Here's a factoring formula you might need for this section. The last page of your book has some factoring formulas, so if you need to look it up, it'll be on there. Section 1.4, solving other types of equation. We can lose a root or gain a root, so be very careful when you're solving the equations. One way to lose the root is incorrectly, you could divide both sides by x minus 1. And when you do that, you get rid of one of the roots. You get rid of the root 1. If you divide each side by x minus 1, you'll have 4x on this side is equal to 3 times x minus 1. So the correct way to do this would bring all the terms to one side. So if you bring all the terms to one side, and then you solve the equation. Distribute, FOIL, distribute again, combine your like terms, and then now, if you can factor it, factor. If you can't factor it, there's quadratic formula, there's completing the square, there's other methods you learned in the previous section. And you have x plus 3 is equal to 0, so x is equal to negative 3, or x minus 1 is equal to 0, so x is equal to 1. This way you do not lose any roots. You can gain a root by squaring both sides. So if I square both sides, I'll have x plus 6 on the left side, I'll have x squared on the right. Move everything to one side. Solve it any way you know, factoring, complete the square, quadratic formula, and this does factor. Equals 0. So x is equal to 3, or x is equal to negative 2. That's what you have. But if you plug this back in to the original equation, negative 2 does not work, because negative 2 does not equal the square root of 4. Okay, so it doesn't satisfy the original equation, though 3 does work. 3 plus 6 square root of 9 is equal to 3. That's true. So be careful if you have to square both sides. You gain roots. Solve. I want to get rid of the denominator, so I am going to multiply each side of the equation by x squared minus 4, or x plus 2 times x minus 2. That's the same thing. So I'm multiplying both sides by that. So I have my equation. When you distribute it to the first term, the x minus 2 will cancel out. Written down there. And then you'll have x plus 2 squared. When you distribute this to the next term, the x plus 2's cancel out, and you have x minus 2 quantity squared. And when you distribute the last term, it cancels out completely, and you have 8 minus 4x. FOIL, and FOIL again. Combine your like terms. So 2x squared, those cancel out, plus 8. Move everything to one side. Oh, when I first started doing it, I could also solve it a different way, but I'm moving it all to one side. Whoops. Hard to read that. So you have 2x squared plus 4x. Factor out an x is common, and also a 2 is common. So if I factor out a 2x, I'm left with x here. I'm left with 2 there. So x is equal to 0, or x is equal to negative 2 are my two answers. But if you plug it back into your original equation, if you plug in x equals negative 2, you have 0 in the denominator. So you can throw that one out. So x is equal to 0 is your only solution. So be careful when you have fractions. Double check to make sure the denominator is not 0, because that's undefined. Let's solve this equation with some square roots. I'm going to take each side, and I'm going to square each side. So when I square the left side, I just will end up with 2y plus 9. And when I square this, you're going to FOIL it. First, outer, inner, last. So then you'll end up with 4, 2 squared. And then your outer and inner terms, when you combine them, will be 4 times the square root of y plus 1 plus y plus 1. But I still have a square root. So now what you need to do is isolate the square root and repeat the process, square each side. So I'm going to isolate the square root. So I moved the 4 over. I moved the y over. I moved the 1 over. And then you end up with y plus 4 is equal to 4 square root of y plus 1. And if you want, you could move the 4 over now, or you can leave it where it is. It does not matter. I'm just going to square it like it is. So when you square the left side, you'll end up with y squared plus 8y plus 16 is equal to, when you square this, you'll have 16 times y plus 1. Distribute. Combine like terms. And you'll end up with y squared minus 8y. You can factor out a y. Y is equal to 0. Y is equal to 8. Double check to make sure that when you plug it back in, it'll work. So when you plug in 0, square root of 9, does that equal 2 plus the square root of 1? And it does. So this one works. What about this one? When you plug that in there, you have 16 plus 9, which is 25. Square root of 25 is 5. And here you'll have 2 plus 8 plus 1 is 9. Square root of 9 is 3. So 5 is equal to 5. So they both work. Factoring by grouping. I can look at the right side, I can look at the left side and see what I can do. Maybe I can factor something out, and it will, I can factor by grouping. So let's see what I can do with the left side. I have an x cubed minus 36x. I know I could factor out an x. Factor out an x? Oh no, I guess I moved it over first. I could have factored out an x and left it on that same side though. So I'm going to look at these two terms here. And that's what I said, factor out an x. This side you could have left on the other side if you wanted and moved it later, or I moved it first. But there's nothing common that I can factor out. But x squared minus 36 is x plus 6, x minus 6. So let's factor that. Now, I have these that are common, okay? Those are common, okay? So I can factor that out, and I'm left with what is circled. So let me rewrite that. I factored out my x minus 6, so that's what that is. And this was the circled part, x plus 6 minus 16. So I'm getting there. And then I can distribute. Can you factor that? Can you use quadratic formula, completing the square? See what you can do to work it out, and really it does factor with a 2 and an 8, one being positive, one being negative. So there I factored it. Now my solution would be negative 8, positive 2, positive 6. And I'm done. Quadratic form. That's not a quadratic, but it can look like one. I just rewrote it. I wrote x to the fourth as x squared squared. So now I have something squared minus 2 times something minus 3 is equal to 0. Now it looks like a quadratic. So let's see if you can factor that. And it looks like it'll factor into a negative 3 and a positive 1. So you can solve this, and you'll get plus or minus the square root of 3. There it is, there it is. And you can solve this and get plus or minus square root of negative 1, or I. And you're done. Again, quadratic form. I'm going to try this one a different way with substitution. You might have done this in Algebra 2, this way. So I'm going to let y, and sometimes you guys used u in the past, equal x squared. So now I can rewrite it as y squared plus 5y plus 6 is equal to 0. So now it looks like a quadratic. So I did substitutions. Because y squared is x squared squared, which is x to the fourth, 5x squared plus 6. Factors into plus 3 plus 2. So y is equal to negative 3, negative 2. But I don't want y, I want x. So do a substitution back in, y is x squared. So x squared is equal to negative 3, or x squared is equal to negative 2. And then solve those. Take the square root of each side, so you have plus or minus I radical 3, plus or minus I radical 2. And those are your two solutions. So it's not a quadratic, but you can make it look like a quadratic. You can either do it by substitution, or the previous way, when I just kept it as x squared. That's the same thing. So whichever way you like better, you can do. This also can make it, you can make this look like a quadratic. I can let y equal the square root of x. So if that y is equal to the square root of x, y squared is equal to x. So substitute in y squared minus 3y plus 2 equals 0. It factors into negative 2, negative 1. So y is equal to positive 2, y is equal to positive 1. But I don't want y, I want x. So substitute back in what y is square root of x. So the square root of x is equal to 2. The square root of x is equal to 1. Square both sides. X is equal to 4.